got notes. All right, good. Okay, I'll get you the assignment for this out today. Probably won't be due until Monday. More than likely tomorrow. Kind of probably looking at some time to work on some things in class. So we'll see where we're at the end of the day with this. But what time, Kaylee? Or 9:05. Okay, 9:05. And if you can't get my attention, you might throw a book or something at me. All right. Okay. If you do throw it, I'll throw it back though. I've never missed either. Okay. All right. You know why I've never missed? You know why I've never missed? I've never had to throw one back.
Didn't you say someone raised?
Yes, I did. It was a joke. So, all right. Hey, guys, 3.1 is titled Functions right here. And I think the thing that I want to tell you about this right here today is the following. You can kind of think of this as some kind of a machine. I'm gonna try and make a machine here. Now, don't laugh at my work, okay? This is a machine right here. Looks like it's something in Willy Wonka's Chocolate Factory. Hopefully you guys don't watch that movie. Have you watched that movie before? I heard that. All right, here we go. Oops. Anyway, you get the idea. This thing is a machine right here. And this machine, guys, I'm going to tell you about this. When I was a kid going through college, I worked in a place called Trimark. And Trimark was a company that made parts for places like John Deere and Winnebago and bless you, Freightliner, right? It blew me away. And part of my job, which was kind of monotonous, and it made me realize, that when I was in college and doing stuff like this, that made me realize that I wanted to finish college, so I didn't have a production job like this the whole time. But what I was looking at doing all the time was this. I would stand in front of this big press machine, okay? I would put a piece of steel in it, I would set it down on the die, I would push this out, and then this big die would come down, and it would form some kind of a housing for some of the latch assemblies that went into these tractors, John Deere, Freightliner, whatever it might have been. And it was kind of cool because this was a company that my dad worked at, and this was a die that my dad had invented and designed, and it was put on the press. And he was the smart one to do all that stuff. And I, as the floor worker, didn't want to be the one pushing the button all the time and doing it. I would find myself looking at the clock and okay, 1 minute's gone by. I'd run 50 parts. I'd look up. 2 minutes has gone by. But every time I put a piece of steel in here, hit the button, I put that same cutout piece of steel in, hit the button, it formed that housing for us. What do you think was true about all those housing parts? Do you think they were exactly the same, or do you think they were different? About the same. They're all the same. Every time I put a flat piece in, it formed it. Every time I put one identical piece in, it kicked out the same exact part every single time. And that's kind of what we're dealing with today. What I'm getting at is this. Let's say that piece of steel that I was throwing into a machine right here was like, pick a number for me. 3. Okay, and then what's your output?
72.
All right, if you can imagine this. Every time I threw a 3 into this machine, this kicked out a 72. So if I picked another 3 to throw back into that and run that part, what's it going to kick back out at, Jagan? 72. Okay, now here's the deal. If I throw a 3 in and it kicks out a 50, is that going to be a good part or a bad part?
Bad.
It'll be a bad part, okay? So what I'm getting at is this. When you input something that's exactly the same, your output should be the same value. Okay, the input, whatever it is, if the input is the same, then it runs through this machine, the output should then be the same as what you get out, all right? So every time I put in a 3, I should always get out a 72. Okay, so kind of think that way. Think that way. Here's what we're dealing with today. Whoops, didn't want to do that. Guys, in section 3.1, that's the whole idea of what a function is. Okay, basically, we want to know what is a function and how is it used in math. And again, this section is really kind of a tie together of what we're going to do in this chapter compared to all the stuff that we've done in the previous chapters. So, goals for the day. Volunteer to read the first one. Go, CJ.
Determine if a relation is a function
Okay, I'll talk about what a relation is here and determine if a relation is a function or not. Basically saying, if I throw a 3 in every single time, I need to always get out 72. I'll determine if that's happening all the time or not happening. How about a volunteer to read the second one? Go, Em.
Find the domain and range of functions.
Let me ask this question. How many have heard of domain and range before? Mathematically, what does it mean? Anybody know? Okay, so we'll explore that here in a little bit. You're going to hear those terms a lot coming up, so maybe be thinking about that, and I'll give you a shortcut to try to remember that. Then finally, last one. What's this one?
Yeah.
Got it, Tori?
Okay. Identify the independent and dependent variables of a function.
Okay, how many have heard of independent and dependent variables before? Recall what they are? They're like an X and Y. You know which is which, Nolan? Okay, so we'll talk about that. We'll make this pretty easy. All right, let's run through some vocab here quickly. First of all, a relation. A relation right up here says that it's going to be a math statement that pairs inputs with outputs. Oh my gosh, just that last drawing I had in there. What was the input value? What did I put into the machine? A 3. What was the output? 72, right? Okay. So basically, what I want you to understand about a relationship is that it's like an ordered pair. It's like an X comma Y. What do you think the first value is? Do you think the first value is an input or an output? Input produces my output. So what I might put over here is this. The inputs, now on a graph, and we'll look at this here in a second, the inputs are typically the X values. Now they're going to change variables up on you a little bit, and I'll show you how to keep that straight. But the outputs then also, what do you think the outputs are going to be?
Y.
They're going to be the Y value typically. Okay, so you might want to jot that down in that box right there. All right, and we're going to get this all organized because a lot of the phrases I use can be used interchangeably. Meaning, if I say domain, I'm also saying a couple of other things as well. They mean kind of the same thing. All right, so a relation, it's a point. All right, how do I determine if a relation is what we call a function? And right over here it says a function is a relation that pairs each input with at most, or I should say, get rid of the at most here. I don't like that, the way they put that in there. I'm going to say that that pairs with exactly one output. So the idea is when you throw a 3 in every single time, 3 in every single time out, we get a, what was our example? 72, all right? This here's kind of my definition. For every X value, there is at most one Y value. What that's saying is this. I don't want, this is what you don't want. You don't want to throw a 3 in and get a 72, and then throw 3 in again and get 73. That's not good, okay? That's not good. So I'm just going to kind of cross this out. If I throw 3 in and get 72 the first time, and then throw 3 in and get 73 out again, that's bad, okay? What it's saying is this. Anytime I put a number in, drop a number in, the output should be the same, all right? How many of you guys have, they have them at certain amusement parks. I think they even have one at the water park. You drop a penny in, you crank this thing, and it kicks out like flattens the penny and it puts their own logo in it. And do they have that at Lost Island? I don't know. I've only been there once. Having a Disney World, I've got one for Buzz Lightyear on it. Pretty excited about that. Okay, Buzz Lightyear is kind of my hero. You know why? Because he goes to infinity and beyond. All right. You're going to hear these terms, domain and range. What's it say the domain is, guys? What's it say the domain is? The input values or the what's it say right here? X values. What about range right here? It says the range is the output or the, I should say the Y values there. All right? The Y values. I can tell I typed these notes watching the Twins last night. Okay. Not the second game. It was a bummer last night. They're a game and a half out now. They have to win today. They have to win today.
Cubs all the way.
Okay.
Netflix all the way.
Independent variable right here. The independent variable is going to be the X values or the input. Here's how I keep independent straight right here, guys. Anytime I talk about independent variable, I always say it is my input value, okay? So one way of keeping independent variables straight is just understand they kind of sound the same at the beginning. Independent variable is in input. That's the value you're dropping in. So the 3 or 72, which one's my independent variable? The 3 or the 72? The 3, the one I put in, right? Okay. And the independent variable is always going to be graphed on the horizontal axis. And then finally down here, dependent variable is the, I don't know why this is doing this to me, the y values or the output. And that'll be on the vertical axis. Okay? Guys, I'm going to put a name up here. Don't take this out of context for me, please. When you were a little kid, you talked about a certain Roy. You remember his name? Roy G. Bibb. That made you remember the colors of the rainbow, yeah. Okay. I'm going to put this name up here. Don't take it out of context. Like I said, remember that name. Here's the deal on this. The R is going to stand for, what do you think? Range, which is a what? Output or what type of values? Y values. The range is an output or the Y values. If I ever use the terms range, output, or Y values, they all mean exactly the same thing. This last name up here then, what do you think this stands for? Not dependent, but domain, input, and X. Now remember, input and independent, they are exactly the same thing. This is how I keep this straight, okay? How do I know which is which? All right, remember that name and you can't screw this up. So if I say I have an output, what else do I have? If I say I have an output, what else do I have? A range and a Y value, okay? If I say I have an X value, what else do you have then? Domain or an input, right? Okay. Make sense to everybody? Okay. So keep that name straight. That helps. So let's jump into this. Let's start talking right here, guys. By definition, a function says for every input, there is at most one output. Meaning if I drop in one number, I get the same number out. All right? So I drop in a 5 and get a 17 out. Every time I drop a 5, I gotta get what out? 17. Okay. So determining right here if a relationship is a function. I'm giving you an ordered pair. And the question says this. Is this a function? The relationships. Are these sets of points a function? All right? Well, when I start listing stuff like ordered pairs here, and I think you guys have a line in this middle one here, don't you? Yeah. Okay, when they start listing ordered pairs here, this is what I like to do. This is what I like to do. I like to make my ordered pairs in terms of an XY table. Okay, I see it a lot better this way for functions. So the first point is what, comma what?
Then 3, 1.
Meaning that when I input a -3, my output always has to be what? 1. Okay, so here, when you input -3, your output is a 1. I'm going to zoom up on this a bit. So when you input -3, your output is a 1. Second point right here is -2, comma what? 1. When I input -2, it says every single time you get out what? What do we get out? 1. How about when you input -1, what do you get out? How about when you input 0, what do you get out? How about when you input 1, what do you get out?
1.
Okay. Determining if points or determining if relations form a function is kind of dependent upon your X value or your independent variable. Okay? Here's the deal. What's true about the outputs every single time? It's 1. Okay? But the question you want to ask yourself when you have a table like this is to say, are there any X values that repeated themselves? Are there any X values that repeated themselves right here? Do any of these X values repeat themselves? Or are they all different? They're all different. Okay? So if that happens right here, this has to be a function because there's only one X, and there's one X input and only one Y output for this right here, right? For this particular input, there was only one output, that value being what? 1, right? For this input, there was only 1 output. For this input, there was only 1 output. Now, what's true about all the outputs? They're all the same, aren't they? But, are there any x's that occur twice up here? Are there any x's that occur the same or multiple times up here? No. So, anytime that happens right here, this will be a function. And I'm going to write, yes, it is a function. All right, so let me show you something that maybe not going to work for us, all right? So you guys have that chart down? You guys have that chart down? Okay. This is a function because, by definition of a function, for every x value, there is only one y value. Okay, there's only one y value. Now let me show you one that might not work out so hot. Page 2 at the top. I'm going to put these values into the table like we did in the previous example. So on set B right here, on set B, here we go. When you input a 1, what'd you get out? When I input 1, a 3. And the next one, I input a 2, what do you get out? When I input a 3, what do we get out? 5. Here we're inputting what again? 1. And what's it say we get out? Any red flags going up yet as I put 4,6 in there yet? Tori, you're shaking your head yes. What's the problem with this table right here in terms of it possibly being a function? Are those points or that relation a function? What's the problem here? What doesn't have the same output? The 1s. Okay, notice right here and here, very problematic. This column right here and this column right here. Notice that question I asked. Are there any x's up here that repeat themselves? What x value repeated itself within that table? The 1. So the first time I threw a 1 in, what'd you get out? 3. The second time you threw 1 in, what'd you get out? 5. Okay, so why is this not a function? Well, here's the deal. If we walked outside at one point at one time and took a temperature at that one specific time, would you get one temperature or multiple temperatures? I'm standing right here, right now at this time. It can only be one temperature at that spot. Could it possibly be 20 degrees and 90 degrees in the same spot at the same time? No. That's what's going on here. We're saying that's not a function because that's not possible. Okay? That's not possible. It's like saying in volleyball, at a certain time in volleyball, maybe this is a dumb analogy, but it's like saying at one part of the game, one specific time of the game, Union Knights have 13 points and they have 22 points because you don't have 27. Okay? Can you have 13 points and 22 points at the same exact time? Not possible. At one specific time, you have one specific value. That's what it means to be a function. So right here, are you going to say this is a function or not a function? This is not a function because it's not possible. It's not possible. I'm going to write it this way, though. I'm going to write it because the input of what input was problematic for us? What one was problematic for us?
1.
The 1 was problematic here and here because the input 1 doesn't produce just one output, but it produces multiple outputs. Make sense? Okay, so the input 1 produces multiple outputs. Okay, so that's your reasoning right there. That is not a function because that one input that happens 2 different times in there. Now, if this would have been a 1 and 3 here and 1 and 3 here, would we have been okay? If this was 1 and 3 again, would that have been good? That would have, because the first time I threw 1, got 3 out. So take a look at this table and see. My question to you is this: is that a function or not a function? Let me say it's a function. Just looking at it. I'll wait for you to think about it. I'm here saying part C is a function. How many say not a function? Okay, those of you that had your hands up, where are you again? Function being a function? Keegan, why do you think that's a function?
Because all of them have like numbers.
Okay. And maybe the question I'll ask you is this, kind of clarifying here. I agree with what you said, by the way. Look at the x values. Are there any x values that overlap or occur multiple times? No. Okay, so anytime I put in 0, it says you get 0 out. Anytime you put 2 in, you get 1 out. Anytime you put 4 in, you get 2 out. Anytime you put 6 in, you get 3 out. Anytime you put 8 in, you get 4 out. So for every x value there, there's exactly one y value. Okay, so good. Part C is a function. Good, very good. Is making sense so far? Making sense so far? Okay. Now, part of your problems are going to look somewhat like this. You're going to have what we call a mapping example. And I want to give you one here quickly in terms of what a mapping example would look like. So let's do this. I'm going to zoom up here a little bit. You're going to see stuff that looks like this in your mapping example. Let's just do this. Let's make an XY kind of a chart right here. An X, put a line, and then put some Y values over here. Okay. I'm going to do this. I'll go -3, -2, -1, 0, and 1. Okay, so those are the X values that we're throwing into the machine. All right, I'm going to put some outputs over here. Maybe like, I don't know, 4, 17, and 62. Okay. And then to that, I want you to draw these arrows like I'm going to do here. I want to do something real quickly. Okay, kind of a goofy little graph there, and that's all right, but here's the deal on something like this. First of all, do you have the arrows drawn like I have? How many arrows are coming off of 0? 1 goes to 4, 1 goes to 17. Okay. Now, guys, which values are my inputs? The X values or the Y values? Which values are my inputs? The X. Okay. So according to this chart right here, if I input a -3, what am I going to get for an output? 4. So according to this chart, the only thing I'll ever get out when I input -3 is a 4. Is that okay? For this 1x, is there exactly one y value? There is, that value being 4. How about -2? When you input -2, what is this suggesting?
62.
You get to 62. You put in -1, what is this suggesting? 62, that's okay. For that one particular input, there was only one output. Problem is when we get to what? 0. When I input a 0, what's the first thing it says you can get out? 4. Or when I input 0, I can also get out a 17. That's like saying right now at this time, you're 4 years old and you're 17 years old at the same time. Not possible. Now, you might be 17 and act 4. That's one thing, but you're not the same age at. That's pretty good, I thought. You're not the same age at one specific. I should take that back. You're not a different age at one particular time. Okay.
It'd be kind of cool. Like, press the button and go.
Time travel, right? Cool. Okay, so do you understand, is this a function or not a function? This is, whoops, not a function because, and maybe I should write this, because 0 maps to what value first? What did it map to first? 4. And what else? Well, and 0 also map to what? 0 map to 17. Okay. I'm going to draw a couple of mapping diagrams up here in a second. You don't need to necessarily draw them. I just want to know which one is a function and which one's not a function. All right? Let me know that you've got that down first. Everybody cool with that? Perfect. All right, a couple of mapping examples. Don't write this down. 1, 2, 3, 4. I'll pick some numbers that I like. How about 31? 31, 31, 31. Oh, you know what? I didn't need to write that many 31. Which one's my function? First one or second one? First one. Why? Go ahead.
I'll go.
Go, Em.
Because it's there on this side, there each number has one output, and then on the other side of that, one number has multiple outputs.
Okay, so the way I remember mapping is this. If there's just one arrow coming off of a number on the left, this is good. Off of 1, there's only one arrow, right? Off of 2, there's only one arrow. Off of 3, only one arrow. Off of 4, only one arrow. What's happening over here? Off of 1, one arrow or multiple arrows? Multiple. Okay, that's bad. All right. So the one on the left would be a function. This is not a function. All right. Good, 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 good. All right. Well, hey, this is what I want to be able to do then. How do you take those relations, represent them graphically, and determine if something represents a function? Okay. This is huge for you right here. Anytime you have a graph, guys, anytime you have a graph, you're going to be using what we call the vertical line test. Okay. Now, a graph might be points, like I suggest in this example. Or the graphs on the next page might be continuous, like we've suggested here. Okay? Well, guys, when you start looking at graphs, you say, is that relationship a function? In other words, for every x value, is there exactly one y value? Well, here's how this works. You start drawing vertical lines with this. Okay? Vertical line test works like this. Something will be a function if what we say passes the vertical line test. In other words, when I draw a vertical line, that one vertical line hits a point on the graph at most one time. And when I say at most one time, that means it can hit it one time or not at all. Okay? First of all, vertical lines. One of my favorite sayings in the world is they say, Carson, how are you today? I say, I'm still vertical. So that's good. Standing up, line. Good. Okay. All right, just check it. Vertical lines, up and down, right? Okay. I'm going to do that. Guys, I see a point right here. If I draw a vertical line right here, how many times does this vertical line right here, I should use a different color, how many times does that vertical line hit the graph? Once. That's good, isn't it? What if I drew a vertical line over here? That's good. Didn't hit it at all. Didn't hit any point that was graphed. Okay? If I continue to draw vertical lines, at most, for each vertical line, how many times will you hit a point?
Once.
One time. That's what it means to pass a vertical line test. If I draw vertical lines, and every vertical line that I can draw hits the graph at most one time, then it's a function. So part of your assignment is going to say, hey, is this graph a function? What test am I using? Vertical line test. And then they're going to ask you to explain it. Well, the reasons are pretty obvious. It either passes the test or it fails the test. You either pass it or you fail it. Okay? So I'm going to say, yes, this is a function. Yes, this is a function. Because it passes which test? Because passes the, and I like to, kind of makes me hungry when I say this because I think of VLTs, but I say passes the VLT, vertical line test. Okay. Passes the vertical line test, right? What do you think so far, guys? Pretty easy, isn't it? Pretty easy.
Yeah, we did this last year.
We talked a little bit about last year. We're going to go a lot further with it this year. So. All right. Anybody need more time with page, what was this, page 3? Anybody need more time, page 3? All right, page 4. You guys tell me real quick on your own. Here's a graph. This graph right here. If you would start drawing vertical lines, here, is that going to pass the vertical line test or fail it? How many say it's going to pass? How many say it's going to fail? And let's check it out. Let's start drawing vertical lines. Draw a vertical line. Boom. There it is. How many times did it hit the graph? One time, right? How about here? Whoop. How many times did it hit the graph? 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 0 times. 1 and 0, good, right? What's the most number of times, or how many times at most will you hit the graph? How many times you draw a vertical line? 1 time. Function or not? Yes. Reason.
It passes the VLT.
Passes the VLT, right? Sounds like you're in some big city and you're on the expressway now. We passed the VLT. How about this next one?
That is a no.
Is this good right here?
No. Oh yeah, that's good.
Is this good right here? Hit the graph how many times right here? Once. How about right here?
Awful.
That's problematic, isn't it? How many times did that one line hit the graph? 2 times. It means for this one particular x value, there's a y value here and a y value here. For one x, there's 2 y's. Or for one input, there is multiple outputs in this situation. Okay, so the top graph right here, yes, it is a function. This one is no. This would be considered a. I'm gonna write it right here. This would, you guys like to say epic what? I call this. This is a VLT fail. Total VLT fail. See, I'm kind of hip. That's a lot of VLT fail. Huh? I am? Cool. All right, you understand vertical line tests and how you apply them to determine if a relation specifically graphs? Understand and determine if something graphically is a function or not? Give me some sort of sign that you're alive right now, yes or no? Yeah? Okay. Example 3, finding domain and finding range. This is the part, and I do not know why, that is difficult for kids. I have no idea why. Okay? You guys remember that name I gave you before? Okay, don't forget that. Roy Dix, right? Roy. What's the R stand for, Roy?
Range.
O,
Output.
Y values, right? The D in the last name. Domain, I,
Input.
X values, right? Finding domain and range of functions. Here's how this works. Finding the domain and range of functions. I have 2 graphs up here. I'm going to kind of split this like so. So I'm going to just kind of draw a line right here. You might want to do the same. Okay. The domain, I'll put here. The range, I will put here. Domain and range. Okay. First of all, you want to decide if you're looking at a collection of points, but they're all going to be a collection of points. You want to know if a graph is continuous or discontinuous. Discontinuous is going to look like a lot of dots. Continuous is going to look like some lines up there. So my first graph, is that graph continuous or discontinuous? It's discontinuous, okay? So here's the deal, guys. I want the domain values, if something like this is what we consider discontinuous. Try and squeeze it up here. OUS. Okay, discontinuous. Okay. The domain. The The domain, the x values or y values? X values. Does that name help you remember? Does that name I gave you help you remember stuff?
Yes.
Yeah. Hopefully. Okay. This first point right here. This is my x-axis here. Horizontal axis is the x-axis, vertical the y-axis. Guys, this first point over here, what's the x value for that first point down here? How far over on the x-axis would you have to move to line up with that point?
2.
What kind of 2 as you went left? -2. So the domain will be -2. That's your first x value. Then the second point, what's the x value of that second point? -1. How about this one? What's the x value for that point? 0. How about this one? How about this one? And how about this one? You okay with that? Okay. Well, if the domain says just tell me the x values for each one, what do you think the range is going to say? Find me the y values of each point. Okay, no problem. Y values, moving up and down, vertical axis. What's the y value here then? How far down is this point? Negative how much? 1, 2, 3, 4, -5, you guys agree? Everybody agree? Ah, that one hurt. By the way, what is this point right up here then? -2 comma what? Well, -2, -5 implies that when you input -2, your output will always be what? -5, okay? What's the next range value? How far down is this point now? -3. How about this third point? -1. Fourth point? How far up is that? 1. How far up is this? 3. How far above that axis is that last point? If I give you a graph that's discontinuous, in other words, points that don't connect with each other, can you identify the domain and range?
Yeah.
You're basically stating what are the x values of the point, what are the y values of the point. Okay? That's pretty doable. Now, if this is discontinuous, what's that make this graph right here? This makes this continuous right here. I'll write this down, get out of your way so you can finish jotting stuff down. That makes this continuous. We already proved that's a function because it passed the vertical line test, right? So now our job is to go ahead and I'm going to kind of cut this off a bit. You might want to do the same. I'm going to draw a line from here. I'm only going to cut it off here at the 4s. So you might want, you know what? Never mind. Never mind. -5 is right here, isn't it? Is that on your graph to say -5? It says x. Well, you know what I'm going to do? I'm going to call this very far left point right here -5. You do the same thing, okay? What's that mean? I'm going to call this point over here at the very end 5, right? So you guys jot that down on the ends. All right. This is one right here that's kind of tricky, okay? Don't lose sight of compound inequalities. Here's how this is going to work. Let's talk range first. Range being what values? X's or Y's? Y's. I'll do range first. I'm going to try and mix it up on you. The Y values. Okay. Guys, what's it appear that the lowest Y value would be down here? -1. What's it appear the highest Y value is going to be in this graph? +1. And we cover all values between -1 and +1. What's the minimum value here? What's the maximum value? So the way you write this when it's continuous is the following. You put your minimum value on the left, in this case -1. And we're going to put this in compound inequality form. -1 less than or equal to. Which variable am I discussing when I'm dealing with range?
Y.
So what are you going to put in the middle? What variable?
Y.
Y. Because I said so. Less than or equal to what? What's the maximum value on it? 1. Basically, you're saying the range of values for that specific graph. The lowest is -1, covers all values from -1 up to what? +1. Okay? So let's do the same exact thing from domain. Because it's continuous, and instead of working up and down, you're going to work from left to right. Boom. Kayla, do you have a question? Got a minute. I'm going to race to get it done. Look at the domain, left to right. What's the minimum value? -5. All the way up to what?
5.
How do you think you're going to write a compound inequality in interval form for the domain of this graph, CJ?
-5.
Yes.
Less than or equal to.
Yes.
Y.
Yes. X. Good.
Is less than or equal to. Y.
Very good. Very good. Give yourself a pat on the back.
Your domain's always your X.
Domain's always the X.
Oh,
Range
duh,
is always
that's
the
one question.
Y value. Is there another problem on the last page here at all?
No, yes.
Okay, yes, no? All right. I'm going to stop there. We've got a few other things to do here. I'll get you your assignment tomorrow. Take a day off. We'll have time in class to work on it tomorrow. Fair deal?
Miss.
All right, let me start recording on this.